So, isotopes. So in Dalton's atomic theory, he originally said that all atoms of a given element were identical. They had the same mass. Well, we discovered later that that wasn't quite true. All atoms of the same element have the same number of protons and the same number of electrons as neutral atoms, but they can vary a little bit in their number of neutrons. So the atoms can vary in their numbers of neutrons. And so we have a word, isotope. Iso is a prefix that means the same. Isotopes, they're atoms that have the same number of protons. They're members of the same element, but they have different numbers of neutrons. The neutrons do not affect the behavior, the properties of that atom in any significant way. There are very slight differences, but for the most part, it really doesn't matter. So how do you know which elements have isotopes? Well, this information is not on the periodic table. Some elements have 2 isotopes, some have 3 or 4. Some elements don't have any isotopes. All of their atoms have the same number of neutrons. So it just depends on the different element. Now, if you have different isotopes, say you have an element that has 2 different isotopes, well, or 3, like neon in this example. So neon has 3 different isotopes. They're called neon 21, neon 22, and neon 20. And so if you have a sample of neon that is enough atoms that you could actually see it or handle it or have it in a balloon or a lamp or something, how many atoms do you think are going to be in there? A few or a whole bunch? About a gazillion, gazillion, gazillion of them, right? Because we said in 1 grain of sand, if the atoms were the size of the grain of sand, it would be as big as Mount Everest. So anything that we can see has just like mind-boggling number of atoms in there. So in that large sample of atoms, you're going to have the different isotopes, but it's not split evenly. It's not 1/3 is neon 20 and 1/3 is neon 21. There is a natural abundance. So for neon, 90.48% is neon 20. That's the most common one. These green ones here, neon 22, make up about 9.25%, and the neon 21 is pretty unusual, only 0.27% of neon atoms are neon 21. This percent distribution, we call it a percent abundance, is relatively constant no matter where you find the neon. Yeah, question?
I had a question.
Mm-hmm.
You said that there can be different isotopes of elements.
Mm-hmm.
So do those different isotopes weigh different amounts?
They do. They weigh slightly different amounts.
So could it be possible that the same element has different densities depending on which isotope it is?
Yes, you could have different densities. To have a single isotope of any size, a sample of a single isotope, you're going to have to do a lot of work to separate it from the others, because they do occur in a naturally mixed arrangement that is characteristic of that element. So neon, whether you can isolate neon from the air, whether you got it from air in Fresno or you got it from air in New York City, if you looked at these percentages, how much is 20 and 22 and 21, the percentages would be almost the same. And so that's called a natural abundance. And those percentages are unique to each different element. Some of them are closer to 50-50, some of them are more like 40-60, whatever. And that's not something that I would expect you to remember. I don't expect you to remember these percentages for neon. I don't even expect you to know which isotopes exist. Okay? I don't remember. We tell each other that with the names of them. So isotope symbols, this is the overall form for an isotope symbol. It's also sometimes called a nuclear symbol. So the big X here is the chemical symbol. the element's one or two letter abbreviation. And then we have stacked superscript and subscript on the left side. Charges go on the right side. This stuff goes on the left. On top is the mass number, and bottom is the atomic number. The atomic number is given the symbol Z. The mass number is given the symbol A. Does anybody else think that's stupid? Wouldn't it make more sense for the atomic number to be A? What were they thinking? They didn't ask me. So for neon 20 is the mass number. And neon has 10 protons. And here's the element symbol. Neon 21 has also 10 protons. And neon 22 has 10 protons. They differ in the number of neutrons. The mass number is the number of protons plus neutrons. So the mass number A is the number of protons and the number of neutrons. So added together. Mm-hmm.
If we get the atomic number, then what's the point of writing the chemical symbol?
Well, that's a good question. If you know the atomic number, what's the point of writing the symbol? Because those always go together. What we'll often find is that we'll leave off the atomic number and we'll just write the element symbol. Because if you just wrote 20 over 10, people would think you were doing math, right? And wouldn't understand that you're talking about different isotopes of an element. What is, yeah?
So you said the mass number was the number of protons and neutrons?
Mm-hmm. Yeah, so it's protons plus neutrons. And so sometimes we need to know, well, how many neutrons does each of these isotopes have? It's actually kind of convenient this way. It's stacked up so that you could just subtract. 20 minus 10 is 10. This one has 10 neutrons. 21 minus 10 is 11. This one has 11 neutrons. 22 minus 10 is 12. This one has 12 neutrons. I really don't know why they use the mass number instead of just telling us the number of neutrons. But, you know, once people start doing things, it's hard to get them to change. So this is what the convention is, and we just have to deal with it. So we can use that nuclear symbol, or we can do it this way. And this gets to your point of why even have the atomic number on there. We can call it Ne20 or neon 20, where we're just specifying the mass number. Because we don't need to specify the atomic number. We've got a periodic table. No decent chemist will be without a periodic table. I have one as an app on my cell phone because you just never know when you're going to need to know how many protons are in an atom of calcium. So it just has to be there. Neon 21 or Ne21, Ne22, neon 22. So when you see something like this, that's a specific isotope of neon. And the number is giving us the mass number. Number of protons plus the number of neutrons. Okay, so we should be able to do things like this. What are the atomic number, mass number, and symbols for the chlorine isotope with 18 neutrons? Well, first we need to know what's the element symbol for chlorine. It's Cl, because we got to find it on the periodic table first. So you should be making flashcards and try to do it without looking up what these are, and then check. Look it up and check and make sure that you're getting it correct. So there's chlorine. What's the atomic number for chlorine? 17. So the atomic number is Z. Atomic number is 17. What does that tell us? 17 protons. The mass number, that's A. Mass number is protons plus neutrons. This has 17 protons. How many neutrons? 18. There's no way you can get that off the periodic table. We have to tell you.
35.
So add those together, 35. So the atomic number is 35. And then it says symbols, plural. So there's 3 different ones we could write. The nuclear symbol, Cl, we're going to put the mass number on top and the atomic number on the bottom of that stacked superscript, subscript thing. The way I remember to put the big number on top is because if I want to know the number of neutrons, I can just subtract. It's all stacked up for me. So that's how I remember that. Okay, so that's one symbol. How else could we name this? Yeah, Cl-35. Or we could write out the element's name, chlorine 35. Any questions? How many protons and neutrons are in the potassium isotope with this symbol? Well, how many protons? 19. This number right there is the atomic number. You could also find, by looking on the periodic table and finding K, oh, K is element number 19. That's 19 protons. But it's actually written right there for us. How many neutrons? 20. So we're going to take this and subtract. 39 minus 19 is 20. So number of neutrons is 20. Any questions? Whole number adding and subtracting.